Hi guys, welcome to the lesson of Laplace transforms. So in today's class, we are going to discuss the solution of system of ordinary differential equations using the Laplace transform methods. So we are given with the two differential equations with the initial values. X of 0 is 0 and y of 0 is also 0, right? And then the differential equations are two dx over dt plus 3 dy over dt plus 7x is equals to 14t plus 7, 5 dx over dt minus 3 dy over dt plus 4x plus 6y is equals to 14t minus 14. So we name these equations as equation 1 and equation 2, right? So now what we are going to do is we are going to apply the Laplace transform on both equations. Let's take equation number 1 and applying the Laplace transform, right? So twice of Laplace of this function dx over dt plus 3 times Laplace of this function plus 7 times Laplace of x is equals to 14 Laplace of t plus Laplace of 7. Right, so we already know that the Laplace transform of derivative, that is dy over dx in general, is equals to sy minus y of 0, right? So this is the general form of Laplace transform for the derivative. So therefore the Laplace of dx over dt is sx minus x of 0 plus 3 times this Laplace of this dy over dt will be sy minus y of 0 plus 7x is equals to 14 over s squared plus 7 over s, right? So Laplace of x is simply equals to capital X, and Laplace of y will be simply equals to y. Or we can write it as x is function of s, right? So for our ease, we are just writing capital X, right? So this is the transformation of equation 1, and we simplified the transformation here, and we take x common in these two elements, and then the equation is formed in this way: x times 2s plus 7 plus 3sy is equals to 14 over s squared plus 7 over s, right? So we named it equation as equation 1, Roman 1, right? Now we'll apply the Laplace transform on equation number 2. So here we applied the transformation. In the similar manner, we are going to deal with this transformation. Here, the Laplace of dx over dt. Here is the Laplace of dy over dt. And here is the Laplace of x and Laplace of y. And then the transformation on the right hand side. So we will arrange the terms. We will take something common. We will simplify the problem equation, and the simplified form is 3sy is equals to 14 plus 7s over s squared minus x times 2s plus 7, or we can write this in this way as well, right? Now we can plug the value of y in equation number 1, right? Oh, sorry, equation number 2, right? So we'll plug this y in equation number 2. So equation 2 implies that x times 5s plus 4 plus 6 minus 3s times this value, that is y, right? So this value is y is equals to 14 minus 14s over s squared. Then we will simplify this equation by taking things common and canceling the terms that are canceling each other. Here we simplified this problem, this equation. All right, so we take the LCM here in this particular equation, and we simplified the problem in this way, right? So this is just simple algebra. You can use simplification methods for simplifying, arranging the terms. Therefore, this is the equation, and then we move to this equation by simplifying, by moving this function on the right hand side. All right, so here we have this function on the right hand side, and then arranging the terms. here we can see that everywhere 21, 21, 42, 42, 42, and negative 21, 84. These all are the multiples of 21. So we can divide all of the elements by 21, right? Because we know that here all the elements are multiple of 21. Therefore, we will get this equation now. S squared plus s minus 2 is equals to 2 minus 2s over s minus negative s squared plus 4 over s squared, right? Now, further simplifying and factorizing the terms, here we are going to do the factorization. Here we can see the factorization. Here we simplified by taking LCM, and now we get the equation for x of s in terms of x, right? So now we can solve for x of t by using the inverse transform to this problem. But first of all, we are going to break this by using the partial fractions. So it would be convenient to apply the inverse transform. So here we applied the inverse transform, but we need to uh, change this into the partial fractions for our ease. Here we are going to use partial fractions. The idea for partial fractions, you are well familiar with that because this topic is a very basic topic. Partial fraction we all learn in our junior classes. So here we apply the partial fractions, right, to find the value of a, b, c, and d. Then we can write the equation easily, right? So here are the values of a, b, and c. Here we solve for c and d, and we get the values. A is equals to 0, b is equals to 2, c is equals to 1, and d is equals to negative 1. All right, and then we are going to apply the inverse transform to the equation. Now we said that it's uh, as over as plus b over s squared. Therefore, a is 0, so it will be b over s squared. B is 2, so 2 over s squared plus. Then we said that c over s plus 2. Therefore, c is 1. So it's 1 over s plus 2. Then we said that d over s minus 1, d is negative 1, so here it's negative 1 over s minus 1. So now it's easy to apply the inverse transform because these are the elementary functions, so we can easily apply the inverse transform, so we get the solution for x of t. Now we are going to work for y of t, and it's easy. Now we can solve equation 1 and 2 to eliminate this dy over dt. uh, we can see here we are given with two equations. These two equations, we can easily eliminate this dy over dt by simply adding both equations, right? So here we did simply add 1 and 2 to eliminate dy over dt. So we get this equation, right? 7 dx over dt plus 11x plus 6y is equals to 28t minus 7. Now we can find this dx over dt. This x is already found, so we will just replace and we will find y from here, right? So 6y is equals to 28t minus 7 minus 11x minus 7 dx over dt. We can plug the value of x here, right? Whatever we get in the upper part, and then we are going to take derivative of x here, right, for this one. So here we get this function. We will arrange, we will simplify, then we will get this form. We will divide the whole equation by 6, and at last we are going to get the answer for y of t, right? So this is the solution for the simultaneous ordinary differential equations, initial value problems using the Laplace transformations, right? So I hope you guys understand this method, and in the next classes we will come up with the uh, transformations for partial differential equations, right? So that's all for the time being.